Okay, now I'm going to show you how one form of energy can transform into another kind of energy using this simple instrument here. We have a spring here, and I'm simply going to stretch the spring, and it's connected to a mass with 4 things coming out of it. So I'm just going to stretch it. And then what you're going to notice here is that as it starts to go up and down, eventually the oscillations, the vertical oscillations are minimized, and it changes to rotational energy. And then after a while, the rotational energy dies down, and it goes back to oscillations. And then after a while, it goes back to rotational energy. And then after a while, it goes to oscillation energy. Okay? So the very basic concept of the idea is that it shows the transformation of energy from one sort of energy to another. When I'm stretching it, what kind of energy am I giving it? Potential energy, right? The potential energy is in the form of what? The potential energy stored in the spring, half kx squared. Okay? Now, if it didn't have the 4 pieces coming out of the end, what would happen? The object would basically go compress all the way, and it would go from potential to potential. In the middle, the object would have kinetic energy, right? So from the 2 extreme sides, most stretched, most compressed, it would be potential energy initial, potential energy final. In the middle, the potential energy would be 0. It would convert into what kind of energy? Kinetic energy, which is half mv squared. Initially, that's what happens when you look at it. Okay? Initially, what happens is it goes up, it has a kinetic energy right here in the middle. And then it goes potential energy, then kinetic, then potential, then kinetic, then potential. Okay? Now, sometime along the way, as it's doing this, the oscillations start to kick in. As the oscillations start to kick in, the potential energy starts to die. And then after a while, what happens? It ends up in the middle somewhere. It ends up in the middle, and this time it's oscillating back and forth this way, right? Oscillating back and forth. So what form of energy is that? That's kinetic energy, okay? But what kind of kinetic energy is it? It's rotational kinetic energy, right? Rotational kinetic energy, what's the equation? Half times moment of inertia times angular velocity squared. Okay? So if we wanted to go more in depth into it, we would calculate the moment of inertia of that. In order to calculate the moment of inertia, we would have to calculate the mass and the radius. Looks like the object looks like a cylinder. So its moment of inertia would be half m times its radius squared. So we would have to calculate its radius. Right? And then it has 4 pieces coming out of it. Okay, like that. So what would be the moment of inertia of that? Well, it looks like those 4 pieces go all the way to the center. Okay? They start from the center. So the moment of inertia of each piece of that is 1/3 ml squared. Okay? Because in physics we learned that if you have a rod rotated about the end, the moment of inertia is 1/3 times its mass times its length squared. But now you have 4 of those. 1, 2, 3, 4. So you have 4/3 ml squared. Okay? So then we would add this. This is, let's call this big M. Let's call this small m. We would add the 2 moment of inertias. That would give us the moment of inertia of the whole thing. Okay? Then we could also calculate how fast it's spinning. That would give us its omega. That would give us the kinetic energy of rotation. that kinetic energy of rotation should be approximately equal to the potential energy that I gave it, half kx squared. What's the k? The spring constant of the spring. X is how much I stretched it. So I could calculate the spring constant of the spring if I wanted to. I could measure how much I stretched it, and I could go and I could make this a full-on lab. Very, very good lab. But let's just show you here just once again so you can kind of see this. You see now? Kinetic energy of rotation. Now, while it has kinetic energy of rotation, it is still oscillating a little bit. The oscillation doesn't completely die. And then it goes back to potential energy. So very, very interesting. Okay, so you can see how useful that is. Very interesting concept there. Transformation of energy from one to the other. Thank you very much.